Hello, I'm Markus. I'm supposed to talk a little bit about technology of decentralization. And we're in the middle of this interesting movement, right? The decentralization movement. A few years ago, we started working on things like diaspora, the federated social web, when we realized we don't want to use a centralized Facebook, we want to build decentralized alternatives. And by now there are lots of technologies, lots of interesting projects in this space that are trying to decentralize the web, decentralize the internet, bring us more privacy, security, trust, to use some of these big words. There are lots of initiatives on all layers of the stack, right? We have some projects operating on very low level, like building open hardware, building mesh networks, building decentralized routing protocols. With projects on the higher application layers, we have alternative social networks, we have email clients that make it easy to encrypt our emails and so on. So there are so many different initiatives and technologies, and sometimes it's also not so easy to figure out how they all fit together. And it's good that we're working on all these different things, but at some point we have to ask the big question, I think. The big question is, well, how do we want identity and personal data and communication to work? How do we want to reimagine the web and the internet and the organization of our communication? We know we don't want it to be as centralized as it is today, but like Kalia said before, there are advantages and disadvantages and of different forms of organization. And so then the question is, how do we want to model that, our identity and data and links? And that's really not just a technical question, that's a very social and political question also, right? The systems, the architectures, the protocols that we build have a direct influence on how centralized or decentralized we are, and as a consequence have an influence on how power is distributed also in society. So we as engineers and entrepreneurs, we have a certain responsibility, I think, to ask that question: how do we want our networks to function? Last few years I've been to a lot of conferences here in this area and also in other places around the world, and often people who are working on technology, what do they ask? They don't ask how does technology make the world a better place. The first question that they often ask each other is, how many users do you have? How many clicks do you have? How fast are you growing? As we're exploring a decentralized network, we should ask ourselves also what are the implications of the technology. And when it comes to identity and personal data and who should control that and how are things linked together, then there's the problem today is that things are not just very centralized, but also they are pretty heterogeneous. Right? Everybody does something else. Every company, every initiative reinvents the basic ideas of identity and personal data. I have a username, password here. I have a username and password there. and so on. So the internet was not built with a common identity system. Some people think there's a missing layer, and the conference that Kalia has been organizing for the last 10 years, the Internet Identity Workshop, has been trying to figure out a layer for the internet that models identity and personal data in a useful way. And one concept that can help to think about that is mathematical construct is a graph, right? So we've been trying to think of our online identity as a graph. A graph is a structure where you have nodes and links between the nodes. So if that's me in the digital world, and I could model my basic information as a little graph, maybe like this. And the graph, I have one node which represents me, and then I have other nodes which, for example, represent my email address, my favorite brands, my credit card details, and so on. And the interesting thing about the construct of a graph is that it can be inherently decentralized, right? So I could have a little graph with me, let's say on my own computer, on my own mobile phone, with some basic profile information about myself. But then I also go to work somewhere. So that's my company, and my company will also have some information about me. We'll also have a little graph with, let's say, my resume or my work performance or things like that. That's when it gets interesting, right? If on the internet, part of my graph is in one place, and another piece of information that's also about myself is in a different place. And with the right technology, these graphs can be linked, right? So there could be a link that says this one node is really me, and the other node is also me, but in a different place, and then we can express a link. And it gets even more interesting when the graph technology that you use for expressing that can cover different technologies. So you don't necessarily have to use the same technology on the entire internet, but for example, in Facebook, I also have an account, right? This is me in Facebook, and Facebook has its own proprietary data model, and there's also some information about me, the things I've liked, and my Facebook friends, and my place where I live according to the Facebook database. And that's a different data model. There's a different proprietary API, but with certain technologies you can still at least conceptually express that this, for example, is the same as this. And so you can start building a model where you imagine a global graph which is distributed and which conceptually contains all the identity and all personal data that's related to me. And that's when things start to become interesting. That's when after that, when you have such a model, you can build things such as access control. You can try to express who can access which parts of my data. You can start synchronizing data. You can map data. You can do all sorts of interesting things with you in control, right? So there's also a little, even though this is decentralized, there's a little centralized element also, which is me being in control of these different parts of my graph. And the point where it gets even more interesting is when there are other people. So this is me. This is all me. And then there's someone else. This is my friend. And my friend also. They also have their own graph somewhere. And it's interesting when you can start relating one individual's graph to another individual's graph. So you could establish a link. Let me try to use my fancy tablet drawing program with different colors. So you could, for example, express that these two nodes in the global graph are different individuals, but they can be linked. It's a friendship relationship, for example. Then you can do interesting things. You can do, for example, something like a decentralized address book. Right? In my graph, I can have my phone number and my email address, and in my friend's graph, that can be their email address and their phone number, and then if you have such a relationship and the right software, then you can always see each other's up-to-date phone number, for example. You can start sharing your data with companies, for example. This is what's known under the name VRM, vendor relationship management. Right? Today companies have huge graphs about all the data about their customers. If you have a model like this where you control your part of the graph, then you can selectively share some of your data with companies that you're interacting with. So this is a little bit the theoretical idea behind having a global graph or a layer of the internet where you can access potentially all the data that is there about you. There are two concrete technologies that I'm aware of, that I've worked with, that can do things like that. One is called RDF, and the other one is called XDI. So who has heard of RDF? Resource Description Framework. Who's heard of XDI? Maybe 2 or 3 people, not so many. So RDF is a graph model that's deeply rooted in the foundations of the web itself. So Tim Berners-Lee, who invented the web, who also invented the foundations of RDF, he has always said that the web is not just a web of documents, but a web of data, really. So you can, using the same constructs and the same mechanisms that we use for accessing documents, for accessing web pages, you can also use the same things for accessing data all over the internet. That's called the semantic. RDF is the leading technology for doing that. And in RDF, you identify everything with a URI, just like web pages have a URI. Also, every piece of data in RDF has a URI. So, for example, if I wanted to model myself with a little bit of data, let's see, with an email address and with a friend relationship to somebody else, it's a little bit of data. That's what I want to model. If I want to do that with RDF, then I have a node. In a graph, I always have nodes and arcs. So I have a node which identifies me. The node has a URI. That's an identifier for the node. It's an identifier for me, basically, and it looks something like this: HTTP something, and then let's say Markus, and then typically as a convention, maybe I have something like this: a fragment me. So that's a URI, and it could be a web page. If I open that in the browser, it could display something, but that's not really the point here. The point is, this is an identifier for me in the RDF data model. And then if I wanted to express what is my email address, then I have an arc going to another node, which is a literal node, and here I would have my email address. Venue, that's my company. And then on the arc in this graph, I also have an identifier which says email address, and it kind of looks like this. For example, for an email, which is an abbreviation. This is just shortcut for also an HTTP URI, which I think looks something like this. xms.com. So everything has a URI. I have a URI. The concept of email address has a URI. If I want to express a relationship with a friend, so this is my friend who also has an HTTP URI. Something else. Let's say Joachim, my best friend today. I don't have space here. Then here I have another link here, and on this arc, on this link, I also have an identifier which for example, is faux friend, which again is also just an abbreviation, a shortcut for a URI. Everything is a URI. XDI is another technology, another graph technology, which is a little bit different. So let me try to do this in XDI. So in RDF, you only have two kinds of links in the graph. You only have two kinds of arcs. You have links between two nodes that have URIs. These are called resources. So you have a link like this between two resources, between two URIs. And you have a link, you can have a link between a resource and the literal concrete data. These are the two kinds of links or arcs in the graph that you can have in RDF. In XDI, there's actually a third kind of arc, which is really the most important one. And in XDI, you have the concept of a root. An XDI graph looks a little bit more like a tree. So if I wanted to model the same data with me and with Joachim and with my email address, then here I would have a root in the graph. And I would have another node here, which identifies me. And now in XDI, the way we identify things it's not a URI, but it's something like this. So it would be equals Markus. So that's an entire different kind of set of identifiers. There's certain XDI specific syntax. Equals Markus, this is an identifier for me. There are advantages and disadvantages of that. The advantage of that, maybe it's an abstract identifier. It's not HTTP, it's not linked to a specific protocol, it's not connected to a specific technology, it's more like an abstract thing. And it has syntax. It has syntax that tells you immediately what it is. So in RDF, you don't know the meaning of something just from the identifier. Right? You look at the URI and you see it's a URI, but you don't know what it is. You don't know if it's a person or an attribute or something else. Whereas in the XDI technology, the fact that my identifier starts with an equal sign means immediately that's a person. So you can read something out of the identifier itself. The disadvantage of that is that it's an entirely separate identifier system. It's not so familiar. For programmers, this is harder to use. You don't know you've never seen that before. It's not as familiar as HTTP or RISE. It's more difficult to get started with. Let me finish the graph. So now if I wanted to say Markus as an email address, then I would have, and in this tree, I would have another node here. And again, there's special syntax. An email address would look something like this. You would have these bracket characters. And then you would say hash email. And then here you would have the literal, the email address. And Joachim would have his own node in the graph, also under the root node. So you see, it looks a little bit like a tree. And then between these two nodes, I can still have a relationship, another node called friend. So it's basically the same data, the same kind of information. It's just a little bit different graph model. One interesting aspect in this model is that an advantage of the XDI model is that every node in the graph has an address. So if you look at the RDF example, and you wanted to somehow point at the email node, this node that is my email address, you want to point at that node. I want to share it with someone, for example, right? I have my email address, I want to share it with someone, I want to give somebody a link to that, to this piece of information. The way I would have to do it in RDF is I would have to tell somebody two identifiers. I would have to give somebody two addresses. I would have to tell them this is me. This is the identifier that identifies me. And then I tell them this is the identifier that identifies my email address. So I would have to give you two pieces of information to be able to point to this one node in the graph. Whereas in XDI, the way things are being addressed, the way you can point to things in the graph, is that once you get to this node here, this node has an address which is the concatenation of the addresses of the parent nodes. So basically the addresses add up, they get added to each other. So if this is Markus and this is hash email, then there's an absolute address. An absolute address for this node which is just equals Markus hash email. So this is one piece of information, one address that I could share with somebody, and this would be a global identifier, a global pointer to my email address that I could share with other people. So sorry, is this a bit too technical maybe, or just and that's it. I'm not going to go into more technology. I just wanted to mention these two technologies are.
Can I ask a question?
Yeah.
So I'm curious, if someone accesses it, like how is this store access? So does someone, by virtue of knowing, Markus, your name, automatically get access to all of that data that's there, or
so this is the address where my data is stored. This says nothing about who can access it and who can do what with it. That's when we get into access control, right? Once you have the basic graph model, once you have the data, you can start creating access control rules. You can start saying who can access what in your graph. In XDI specifically, there's a mechanism called link contracts. It's called link contracts. That's how you can express who can access what. And that kind of information is actually also part of the graph. So within the graph, there would actually be a lot more nodes here. There would be many more nodes on the equals Markus, which then say who can access what. So just by knowing the identifier doesn't necessarily give you access to it. But that's something that I would configure. I would set that up. I would say.
But then doesn't this mean that it's necessarily a centralized system, because then there has to be the access control layer has to be managed centrally?
The access control layer is where the data is. The data, I have my part of my graph wherever I choose, right? I can have my graph on my own server, and that's where the policies get enforced, and that's where access control happens. That's the same in XDI and RDF. The data, you have a server, right? The data lives on some kind of server. The server has an API, that's how you can interact with the graph. You can have applications that talk to the graph, that communicate with the data, and the applications communicate with the graph that lives on some server. And that's where the access control happens. That's where it gets enforced. But I have my graph here, and you have your graph there, and everybody has their own graph. But the project that I like very much is the Freedom Box. So I think you would have a Freedom Box at home, and that's where we would all have our own individual parts of the graph. So that's it basically. These are two technologies that I know that you can use to kind of realize this vision of a globally distributed graph where everybody has their own part of the graph, and where you can link things and write applications that do interesting things with it.
If you have access to both Markus and Joaquin, can you make a path that's equal Markus, equal Joaquin hash value to extend the path through somebody else's identity?
No, you cannot do that. You can. So that, I don't know if you heard that. The question was can you say that question again? If you
So could you construct a path that's equal Markus, equal Joaquin, and then get to say Joaquin's hash email?
like something like this, if there was you cannot do that. In XDI, you can give access to any node in the graph. I could allow you to read this part of my graph, which means you are allowed to read my email address, but I could also allow you to read this part of the graph, and it would cover everything underneath it. So then you would have permission to read everything about me, my email address, and everything else. But it would not give you access to this. This is a separate branch in the graph.
So if you want to get all of your friends' emails, you have to walk back up the tree and then look for all the identities that you have access to relative to the
if you want access to all of your friends' email addresses, then you would go to their graphs, and they would have to set up the permissions in their graph. Right? I cannot allow you to access Joachim's email address. That's something he would have to allow you.
How do you do that permissions if it's self-hosted? So how do you verify that Noah is, who Noah thinks he is? So Joachim wants Noah to be able to access his email. How do you verify?
Okay, so how do you verify
Some external.
some identities in XDI and in RDF? There's a similar mechanism. There's basically a PKI in place. So everybody who participates in this, everybody who has their own graph, who has an identifier, has a PKI, public key infrastructure, so everybody has a key pair. So when you try to access my graph, you send a request to my graph, to my server. Then you sign the request, to put a signature on your request. And my server can verify that it comes from you, so it can look up your public key. In RDF it's called the web ID. In RDF you have URIs. In RDF, this HTTP URI that identifies me would have an associated key pair, public key. It's called that. That's when it gets called the web ID. And everybody can look that up. So I can give you the URI that identifies me in the RDF graph. This is my URI, markus.it/me. I give you that, and from that you can find my public key. So if I send you a request and I sign it, then you can just verify it.
But there's no notion of group access or identities or something like that.
There is, yes. So there's also no notions of group membership. Yes. But first you have to verify that the one who's talking to you is really the one he claims to be. And then the next step, that's authentication, and then the next step is authorization. That's where you can, that's where you know who that person is, and then you can check, for example, is he a member of the group or not. So that's also something that exists in RDF and XDI. Maybe one difference between the technologies here is also XDI community creating XDI, or the place where it comes from is maybe a little bit more centralized in RDF, because in XDI there's one well-specified, well-understood mechanism for doing these things, for doing authentication, group membership, authorization, and so on. Whereas in RDF, there are many universities, many PhDs, it's much bigger than XDI. In RDF, there are many different people working on it, and for example, I'm aware of, I think, 5 different ways of how people have done access control in RDF. Even different, so even that is a little bit decentralized, right? There are different ways of expressing permissions, of expressing control with different advantages.
So, I think when there are more questions, then we would move it maybe a little bit later to the session. So Markus will be
Yes. So
around, and you want to wrap up.
yes, this is basically it. Like I said, one project that I like very much is Freedom Box project. If you've heard about it, it's a small personal server device that you can have at home. And I have a few prototypes here. They have both RDF and XDI on them, so we can experiment with.
Where's the Freedom Box?
Yeah. Any more questions? Then I say thank you.
Yes, about Freedom Box, where you can get it.
Oh, sorry.
I was just asking where it's made.
Where it's made, the Freedom Box. The Freedom Box is a typical open source project, very decentralized, very little bit chaotic. It's a typical open source community that people all over the world working on it. Right now, there's no place where you can actually buy one and it just works, but you can. But we're working on that, so this is something that we might have pretty soon, maybe. But there are ways to get one. So you can get one. You just have to install it yourself. It's not so easy to get it working. But I'd be happy to demonstrate in the coming days.
Nice. Thank you. So yeah, besides Markus, we also have listeners. So if you have questions to link data,